Welcome to the Finely Tuned Infrastructure Podcast by Rhythmic Technologies. Halloween is here. And, well, for retail IT teams everywhere, this is it. It's kind of the last deep breath, the final calm day before, the total intensity of the holiday season. And Black Friday just hits full swing.
Absolutely. It's that quiet before the storm, before the transactions really start flying. And if your traffic spikes 10x like it often does, you're facing the ultimate pressure test. And what Rhythmic's recent analysis really digs into is how the main worry for IT leaders has fundamentally shifted over the last couple of years.
Yeah, I think we've all felt that shift, haven't we? Retailers, they've put years into optimizing everything. Moving to the cloud, getting top-notch CDNs, tuning checkout flows, right-sizing instances. The blog points out, and it's true, that technically that core infrastructure is probably faster, more solid than ever.
That's exactly it. The old fear was just, will the server stay up? And today's infrastructure is, frankly, incredibly resilient on that front. The core worry now isn't really speed or even uptime in that old sense. It's knowing. It's about having that immediate end-to-end view into this sprawling, multi-vendor world that modern retail actually runs on. When things are running smoothly, great. But under stress, those connections, those seams, they can tear right open.
Okay, so that's our focus today then. Moving beyond just, is the site healthy?
We need to understand why just watching your own servers isn't enough anymore. And instead, really focus on those hidden weak spots, the seams between systems that Rhythmic talks about, the ones hiding in plain sight in today's retail tech.
Yeah, and to really get the scale of this, you have to picture that sprawl. Infrastructure used to be maybe your platform, your database. Simple enough now. Your online store is really a gateway for maybe 20 different vital services all talking at once. Right. And that data flow gets incredibly complex. Rhythmic lays it out. A customer clicks add to cart, right? And that single click, it kicks off a request to inventory, which might ping fulfillment, which then calls shipping providers just on the back end.
And that's just half of it.
Exactly. Meanwhile, the front end is firing off calls for real-time fraud checks, pulling data from personalization engines, running A/B tests, sending data to analytics vendors.
It's like this complex distributed orchestra, right? Beautifully engineered when it works, but hit that Black Friday peak, say 11 p.m. You need absolute perfect harmony. If just one tiny part, one piccolo player is off key, the whole thing sounds awful. If something breaks, the question becomes, what broke?
Right.
Where? And how do I fix it now? You just don't have 20 minutes for triage then. You need instant visibility across that whole flow.
Which brings us straight to that case study Rhythmic shared. It's pretty chilling because the symptom was so hidden. They talked about a mid-sized retailer last November watching their checkout completion rate just drop, 23% over 90 minutes.
And the first reaction, total confusion. All the traditional dashboards were green. Servers looked fine, error rates low, platform response times seemed normal. But everyone was looking in the wrong place because the problem wasn't inside their own cloud environment.
And the culprit turned out to be an external third-party fraud detection vendor. Okay. They had implemented rate limiting quietly the week before. Now, rate limiting is usually protective, isn't it? So what exactly happened? How did that simple vendor change cause such a massive performance hit?
Well, that gets to the heart of this invisibility issue. See, rate limiting doesn't usually throw a big, obvious 500 internal server error that your basic monitoring would catch right away. Instead, what happens is the vendor system starts, queuing your requests. It makes them wait in line. So the vendor accepts the request technically, but maybe takes 30 seconds to process it instead of the usual half second.
Okay. So your main platform is just sitting there blocked, waiting for that security check it needs.
Precisely. It's what we call a synchronous dependency. It has to wait. So if the retailer's checkout normally takes, say, 8 seconds start to finish, but that external fraud check suddenly jumps to 40 seconds because of this silent rate limiting, well, the total transaction time just balloons to 45 seconds, maybe more. Customers bail. They see that spinning icon and they're gone. The site is technically up, yeah, but your conversions are tanking because of a bottleneck happening miles away, completely outside your normal monitoring view.
That really drives home the limits of traditional monitoring. It was built for a world that just doesn't exist anymore.
It really does. Traditional tools check the health of your stuff. Database CPU, web server latency, you know the drill. It completely misses performance slowdowns at those critical integration points, those seams between your system and the, say, 20 external services you depend on.
Okay, let's maybe list a few more of those hidden failure points the blog warns about. Those specific spots that only really buckle when traffic goes 10x. We touch on third-party analytics scripts. They're essential for business insights, but what goes wrong under heavy load?
Well, analytics scripts, particularly the ones running in the user's browser, can suddenly become a huge drag on page load times. Maybe they're waiting for a slow server response on their end. And when you've got, I don't know, 10,000 users hitting the site at once, that tiny delay multiplies and cascades. It pushes your site's performance metrics way down, costing you precious seconds right when the page should be rendering.
And then there are the systems that are absolutely core to the transaction itself, like payment processing always in that critical path.
Always. And a few hundred extra milliseconds of lag in the payment gateway's response. Maybe you don't notice it on a slow Tuesday, but multiply that slight delay across thousands of simultaneous checkouts on Black Friday. The user feels that lag, it feels sluggish. So monitoring here isn't just, is it up? It's constantly tracking the median and 95th percentile latency for that specific external call.
You also mentioned A/B testing platforms. That's maybe not the first thing I think of as a potential bottleneck.
Oh, they definitely can be, depending on how they're built. If the platform needs complex real-time logic to decide which version of a page a user sees, like, is this a new visitor or a VIP member? That decision, that segmentation, has to happen almost instantly. If that segmentation platform gets overwhelmed by the load, it slows down the whole process of even showing the page content. This is especially true for platforms doing heavy server-side work to assign experiences. That adds compute latency before the page even starts to render.
So it keeps coming back to this.
Mm-hmm.
These systems aren't necessarily crashing and burning with obvious errors. They're just slowing down.
Yeah.
Enough to kill the user experience. That's the degradation trap you mentioned.
That's the trap, exactly. Your
Right.
servers look healthy, error logs are quiet, everything seems fine,
Right.
but your conversion rate has inexplicably dropped 15%. You are flying blind. You've got this critical visibility gap, and it's costing you real money every minute. And without the right kind of end-to-end monitoring, you could waste hours, literally hours, looking at the wrong parts of your system.
Okay, now speaking of adding complexity, the blog points to a major new factor many retailers added this past year: AI-driven personalization. How does this new tech change the game for peak traffic?
Well, it introduces a totally different kind of demand right into that critical path. Think about older retail sites. A lot of content was static, maybe based on simple rules, easy to cache at the edge with a CDN. But an AI recommendation engine, it's generating personalized product suggestions by making complex inference calls for basically every single page view.
So instead of just serving up a pre-made image or block of text,
Yeah.
you're actually running a machine learning model in real time to decide what that specific user sees.
Precisely. And that takes serious computation, often hitting specialized hardware like GPUs. Now scale that up. When you hit 10x traffic on Black Friday, those inference calls need to scale massively, instantly, or they need to be cached extremely smartly, very aggressively. The risk here isn't just about scaling your servers, it's finding out the hard way that your AI vendor's standard compute tier just wasn't designed for the sheer volume of simultaneous inference requests Black Friday throws at it.
And that's a test that probably only happens for real once a year. If that whole flow, including the AI piece, hasn't been properly load tested end to end, you won't find that bottleneck until it's actively costing you sales.
It's another absolutely critical dependency, totally outside your direct control, but completely essential to the user experience and ultimately conversion. Your visibility now has to go beyond just standard cloud metrics. It needs to account for the latency introduced by these sophisticated dynamic external computations too.
All right, let's shift towards solutions then. What are the successful retailers doing differently? The ones who seem to, metaphorically speaking, sleep through Black Friday without major incidents.
Well, they've definitely moved way past basic server checks. They track the entire transaction flow. Withmik really emphasizes this. Success hinges on comprehensive tracking that follows a request through every single hop, both internal and external.
Okay, so that means tracking the full end-to-end time, right? From the first click to the final thank you page. Plus, meticulously measuring the performance of every single third-party service that's critical to making that sale happen.
Yes, and they get incredibly granular about it. They use things like distributed tracing. This basically assigns a unique ID to each user request as it enters the system. Then you can see exactly how long that specific request spent waiting for the payment gateway, how long the fraud check took, how long the inventory lookup took. So if a transaction suddenly takes 45 seconds, distributed tracing tells you instantly where those 45 seconds were actually spent.
That sounds like exactly what was needed in that fraud vendor case study. It would have pinpointed the 40-second wait on the external call immediately.
It's pretty much non-negotiable for complex systems now. They also lean heavily on synthetic monitoring. This means setting up automated bots that run 24/7, constantly simulating real customer journeys, browsing, adding to cart, checking out. And these bots measure the performance, the latency of all those external dependencies, even during quiet periods. It helps catch those slow, creeping performance issues before they become major problems during a peak.
And we shouldn't forget the internal metrics that still matter for peak performance, right? Like tracking CDN cache efficiency, origin hit rates broken down by region, and database query times, not just overall load, but which specific queries are slow.
Exactly right. When your database load spikes, knowing which specific query is the culprit is crucial. Is it blocking other things? And detailed CDN metrics tell you if maybe a bad caching rule is suddenly sending way too much traffic back to your more expensive, slower origin servers. The retailers who succeed see these degradation points almost instantly and can isolate the cause. They're not guessing, they know.
Getting this level of detailed visibility obviously requires a lot of proactive work well before November hits. What are those key pre-holiday steps that Rhythmic highlights?
It really starts with meticulous mapping and documentation, understanding every single dependency, internal and external, identifying every potential single point of failure. Retailers absolutely need to know which external calls are synchronous and blocking, meaning if that service hiccups, the whole checkout process stops, versus asynchronous ones that can maybe fail more gracefully without halting the entire transaction.
And maybe most importantly, actually having those tough capacity planning conversations with every single third-party vendor. You need clarity, maybe even contractual guarantees about the throughput and latency you can expect from them during your peak load.
That conversation is so critical. You absolutely cannot afford to discover on Black Friday itself that your fraud vendor's rate limit kicks in at, say, 50 requests per second when you're suddenly trying to push 500 through. It really requires partnership and clear communication between the retailer's team and all their vendors.
It seems like even though internal teams know their own core systems inside out, getting this full view across such a wide distributed landscape often needs specialist help.
It often does, yeah. Because instrumenting your applications for distributed tracing, setting up sophisticated synthetic checks across maybe 20 different services and APIs, that's complex work. It requires specialized skills in integration performance analysis, distributed systems observability, skills that might be outside the day-to-day focus or just the available bandwidth of the internal team, especially in the busy run-up to the holidays.
Which points to the value of bringing in partners with experience, doesn't it? People who've been through dozens of these holiday peaks with different retailers, who've seen the common failure patterns with various integrations. They know where to look, where to put the monitoring hooks to catch those silent problems. And crucially, they might have the focus time in, say, October to get that observability framework built while the internal folks are nailing down code freezes and other prep.
Yeah, the essential difference really is the quality of the information you get from your monitoring. The goal is to set up systems that tell you what is wrong, like vendor X is rate limiting us, or the database is getting hammered by this specific slow query. That's actionable. It's very different from monitoring that just confirms that something is wrong, like, uh-oh, conversion dropped 15%. That just leaves you scrambling and guessing.
Which loops us right back to that core question Rhythmic raises in the blog. And it's a question for you, the listener, to really consider. Is the monitoring you have today built for the reality of your infrastructure, for that distributed multi-vendor system you actually operate, the one relying on maybe 20 different external services? Or are you still kind of operating under the old assumption that if the site is up, then everything must be okay?
November 1st is really the deadline to answer that question honestly and with confidence. Because, as Rhythmic's analysis clearly shows, the retailers who find out they have critical visibility gaps on Black Friday, well, those are the ones who see significant revenue impact.
Those are really vital insights for any IT leader getting ready for the next intense few weeks. You can find the original Rhythmic analysis, which goes into more detail on things like distributed tracing and specific metrics, over on their site.
And it's worth noting, Rhythmic is doing some rapid infrastructure reviews right now through mid-November, just providing some honest feedback on where you might have blind spots before the peak traffic really arrives.
Good to know. Well, this look at modern retail infrastructure challenges brought to you by the Finely Tuned Infrastructure podcast. It was actually generated by an AI based on Rhythmic Technologies' original analysis. You can check out that original content and find more resources at rhythmictech.com.